Thanks for joining today's SONiC OCP session. This is Xin from Microsoft. I have Li Hua, also from Microsoft, joining me. Together, we are presenting the SONiC community to deliver the SONiC 2020 update. The talk will be organized as following. First, I'm going to give a high-level SONiC community update since last summit. Then Li Hua will give a close look into one of the technical area, multi-ASIC and chassis support. He will also cover what's coming in the near future. So, looking backward, in the last 2 years, SONiC has been growing rapidly. We have around 4 million Ethernet ports installed, coming from reported partners. We have created 9 SONiC working groups and 4 side working groups to support the fast-growing scenarios. The active code contributors on the GitHub has been growing from 200 since last year to 280. The supported platform has been growing from 60 to more than 19 this year. These are also reported numbers. Then let's take a look on 4 other areas. First of all, in the documentation side, that in order to help a user to easily adopt the system, we updated a detailed user guide as well as CLI reference book. We also create the latest architect documentation as well as the outline of repos to help new developers to understand the system better and they're able to navigate across the repos to contribute code. We also systematically publish newsletters, release note, as well as all the discussings, technical discussings, has been recorded and published online. Here we thank Dale and Avis in the documentation group to lead this effort, as well as the whole community support. Last year, we published 2 releases, 2019-04 and 2019-11 release. There are many interesting features and capabilities being added. Just to name a few. First, we upgrade the kernel and corresponding Dockers to Debian 4.9. We also delivered a very high demanded feature, EVPN WRF. We also invested heavily in the management framework, so that user will be easier to manage the system built on top of SONiC. On the diagnostic point aspect, that we beef up job counters, Everflow, and hardware resource monitoring. There are many other features. I encourage you to go to the roadmap on SONiC GitHub, on SONiC Wiki for the detailed release, detailed list of features in each release. Here, I would like to call out special thanks to Broadcom, Dell, Mellanox, Alibaba, LinkedIn, Nefuse, Avis, and Microsoft for contributing code to these releases, as well as the whole community for jointly doing testing, issue reporting, high-level design discussing. Together, without this joint work, we want to be able to deliver the release together. There are many ASICs joining this family to support SONiC. Just to name a few, Cisco Silicon One, Broadcom Trident 4, Tomahawk 4, and Jericho 2, and the Mellanox Spectrum. On the new scenario front, people from community are working on 400 gig load balancer as well as edge scenarios. In the ecosystem, first of all, we thank all the community members who has been with us in the last 2 years. Together, we have growing the community, growing the SONiC release after release. We also welcome new members who joined since last year. We have eBay, Quideo, Comcast, and Target joined recently. We also have many hardware vendors, for example, Nokia, Stories, Inspire, Octara Networks, Soft Iron. They provide SONiC on top of their hardware platforms. We also have system vendor, system solution partners like Key Insight invested in SONiC test platform inside the packet, as well as Crito and Highwell working on ultra low power cable to support SONiC system. There are many interesting and exciting projects in the community. In the rest of the talk, I will give time to Nihua to focus on in one of the area, that is multi-ASIC and chassis support.
Yuan, I work for Microsoft Azure. Thank you for joining the virtual OCP summit and join me for a quick update on SONiC's support for multi-ASIC devices and modular chassis. This topic has been raised by many people ever since the first day we announced SONiC in 2016. And now, with the great contributions from many companies and individuals, after days and weeks of long joint working sessions, we felt that we finally reached a point where we have a general consensus on the approach that we're happy with, and we're ready to marching on to the detailed design and execution phase across the industry. I'm really excited to share with you the updates here. So let's start by taking a quick overview of the different categories of networking devices. Please pardon me for a grossly oversimplified representation of networking hardware. So single ASIC devices are relatively simple. It typically has a single ASIC that provides the data plane functionalities and a single CPU that executes the operating system and provides the control plane functionalities. Multi-ASIC devices will have multiple ASICs that are interconnected to provide the data plane functionalities, but typically they still have a single CPU for the operating system. Modular chassis are quite a bit more complicated. They typically have line cards that in itself is already a multi-ASIC device, and with its own CPUs and ASICs. And these line cards are then interconnected with fabric cards. Fabric cards can have many ASICs, and the supervisors, or sometimes they call it the route processors, will typically host the CPU and the operating system that manages the fabric cards, as well as the environmentals of the chassis. With the added complexity of multi-ASIC devices and modular chassis, a key challenge to us is how can we design an operating system that can realize the beauty of the hardware, but without complicating the software. If you are a Lego fan as I am, then you'll see that the key here is to Legolize the building blocks for maximum component reusability, and then have a good blueprint to put things together for a coherent purpose. Let's have a quick recap of SONiC's container architecture for single ASIC device. This will be our fundamental building block. In this architecture, SONiC provides a set of core containers: switch state service, the Redis database, and the syncd container. And then there is a set of application level containers, for example, BGP or TeamD, that provides protocol functionalities. All these containers are managed by systemd services in Linux. And how can we extend this to the multi-ASIC device? Linux namespace actually is a way that provides a clean and isolated networking environment for processes and services. We created one namespace per ASIC and run a Docker stack and the corresponding managing services for each ASIC inside the associated namespace. Note here that we consciously choose not to simply replicate everything containers like SMP, PMON, telemetry are not replicated. This is based on feedback from our operational experience. People still want to have a single unified view of a box instead of being exposed to the internals of a device and have to deal with them. For modular chassis, how can we further extend SONiC to support modular chassis? One natural thought is actually to build a monolithic OS and then keep on replicating all the containers to cover all the ASIC in the devices. However, after a lengthy failure mode analysis, we decided to take another approach in which we replicate the SONiC instance itself for each line car. The line car itself is already a multi-ASIC device, so we'd be using the same namespace idea we just talked about earlier. The fabric SONiC, which runs the supervisor, would manage the fabric ASICs. It would also provide the chassis platform management, internal connectivity management, and a global database when line car SONiC needs to communicate with each other. At this point, I bet many of you would be asking if the architecture is applicable to VOQ-based systems. The key distinction of a VOQ system are the following 2 points. First, VOQ provides a clear separation of ingress and egress pipeline within the same chip, all spanning multiple chips. Second, VOQ have a separate output queue at the ingress per output port. So, because of the difference, the missing piece here is actually a good side model that can describe the forwarding behavior of VOQ and cell fabric. And with a great contribution from Broadcom, Arista, and Nokia, the SI community has worked together to create the VOQ SI. And this is in the final phase of vetting at the time of this video recording. With the addition of the VOQ SI, we believe the proposed SONiC architecture would work in a very consistent fashion. Now we have talked about all the components. Let's take a look at how we can use a simple standard routing paradigm to put building blocks together. For devices with Ethernet-based chips as cross-connect, we can use a port-to-port VLAN tag switching, or as what we proposed last year, a VXLAN-based port switching. And then the front panel AC will have a full mesh BGP peering for raw exchange. For devices with VOQ or cell-based cross-connect, we have devised a scheme for IP BGP peering can still be set up over the fabric. Due to time limitation, I'd refer you to the side talk from Broadcom team. Now, let's take a look at the demo video of the SONiC running on multi-ASIC device. Thank you very much.
Hello, today we'll see a demo of SONiC on a multi-ASIC platform. For the purpose of this demo, we'll use the topology depicted in this slide. In this topology, the T1 node is a multi-ASIC device which is connected to 4 T2s and 20 T0s. This multi-ASIC platform has 6 ASICs in it. ASICs 0 to 3 are the front-end ASICs, while ASIC 4 and 5 are the back-end ASICs. Each front-end ASIC has 2 port channels, one each for both the back-end ASICs. IP addresses are configured on this port channel, and there is IBGP running between front and back-end ASICs. In the demo today, we'll show bidirectional ping between 01 T2 to 20 T0. So in this screen, the top window is the T1 device, and the bottom windows are T2 and T0 respectively. So in SONiC disaggregated architecture, each ASIC has a Linux namespace associated with it. So on this device, there are 6 ASICs, so there are 6 Linux namespaces configured. The SONiC Dockers are replicated for each of this namespace. So there are 6 instances of SWSS SWSS 0 to SWSS 5, 6 instances of SYNC-D, 6 instances of BGP running. If you look at the IP addresses on A60, A60 has 4 port channels. Port channel 0 and 1 are connected to the internal or backend ASICs, ASIC 4 and 5, while the other 2 port channels are connected to 2 T2 devices. Similarly, on ASIC 3, there are 2 port channels between ASIC 3 and ASIC 4 and 5 respectively. So let's try and ping from 01T to 22T0. So from 01T2, I'm trying to ping the IP interface of 22.0. And similarly, let's ping from 20T0 to 01T2. Okay, let's send a large number of ping packets to see how the packets are routed within the multi-ASIC platform. For this purposes, let's look at the interface counters for A60. Sorry, A60. So here you can see that the incoming interface is Ethernet 4, which is member of port channel 2 connected to 01T2. The packet is then transmitted to an interface connecting to backend ASIC 4. If you look at the interface counters for backend ASIC, we can see that the packet is coming in on backend ASIC interface BP284 and then is transmitted out to an interface connected to ASIC 3. Now, if you look at the interface counters for ASIC 3, packet is received on an interface connected to ASIC 4, which is the backend interface, and is then transmitted out of the front panel port Ethernet 252 to T2 devices. Similarly, the reverse path packet is received on 252, sent to a backend ASIC, and then sent to ASIC 0 to be transmitted out to 01T2. Thank you.
Thank you, Lihua. Now I'm going to conclude this talk by turning to you, SONiC members, as the builder and players. We welcome you to participate in many different ways, such as you can add a missing piece. There are multiple scenarios has been worked on in the community, but there are lots of other interesting ideas has been floating and waiting for you to participate. You can also build image, install it and test it, file issues, or participating in design doc, discussing and giving your feedback. You can find the mailing list, wiki, source code in the following URLs. By saying that, thank you everyone for attending this session. Now we are going to open for questions. Hello, can you guys hear me?
I can hear you, Xin. I'm not sure if the audio is shareable.
Okay, there is a question on the chat window about will we able to configure BGPR number through SONiC CLI or through raw FRR only? So we This BGP unnumbered is on our 2020 June release target. We will go through the design review very soon in the community. Each feature coming to the community will go through the design review, code review, and as well as test review. So my ask for you is, Alexi, thanks for your question. Come to the design review to find the details of how this is designed and implemented. So ideally, for all the features we have, we will have a way to configure it either through configuration file or through CLIs. But the details, let's still find it in the design spec from the contributors. Okay, there is a question coming about what is happening with Silicon One. I'm going to take this. So as you have seen that Cisco has announced that Silicon One supporting SONiC. It's in their public PR. For details please contact Cisco for the roadmap timing.
And
what?
Yeah, sorry. Can I chime in here? So actually, at a SONiC workshop earlier, around March, Praveen have talked about the project. So you can probably find some video there as well. And yeah, so that's probably yeah. So you can find information on OCP as well. Yeah.
Okay. So I will also post the link of the previous workshop on OCP. You can find it has been all recorded and published on the OCP web. Please find in the chat window the workshop happened in March. Look for Praveen from Cisco, his video.
I see one question about when do you plan to implement EVPN Type 2? If I'm not mistaken, I think the community version of EVPN support is already in there. Yeah, I think that there's maybe you can check on that a little bit, and the EVPN working group does have some information there. Okay, what is the target deployment use case driving multi-ASIC or chassis-based boxes? Yeah, so I think as we explained in the past, in Microsoft's motivation, right, our network at a tier 0, tier 1 is a single ASIC device, while in tier 2, tier 3, that's the data center spine and regional network, we typically use chassis devices. So that's the first early phase target deployment. And certainly our wide area network is also using chassis devices. So that's probably a little bit further down the road.
Okay. I'm going to the next question. So the question is, in the demo that we showed, which silicon ASIC was being used for the demo? So actually, Yuhua, would you like to take this?
Yeah. So what I was hoping for is people pay more attention to the container layout instead of the ASIC specific. But that specific ASIC is the Trident 2, if that's a question. Yeah, so the design will support all kinds of ASICs interconnecting together.
Yeah, the key point here is the software model is similar for multi-ASIC as well as for chassis. That's the idea that we want to demonstrate. There is a question on when do you plan to release 2020 June, in June or a little bit later. When will it be accessible on GitHub? we do plan to cut the branch on time, June 30th. We used to cut branch. After that, it will take some time to stabilize. Actually, the feature has been already started to checking into the master GitHub, the master branch. You can already access it. It's all accessible to everyone. We also have a bi-weekly issue triage meeting on Pacific time morning 8 to 9, which many people has been already testing the image from the master branch and start to report issues. Okay, there is one more question coming from the Q&A. Interesting question comes from both chat and Q&A tab. This question is, what is the expected schedule for incorporation of Psi for Phi? Phi meaning that Psi incorporated abstraction for Phi functioning component, and are all silicon vendors on the same schedule for incorporating Phi functionalities control here inside?
So Xia, I can take this one. I think sure. Part of the reality, right, Psi being a header, right, is that all the ASIC vendors are on different time schedule for almost certainly, right? And even for the same vendor, when they have multiple Phi chip, they have different priorities. So I think that that's the binary support for different chip is going to come at a different timeline. There are certain Phi chip already support Psi pretty well, right? And so I think as with the ASIC support, we expect the support of Psi for Phi to expand over time.
Any other questions?
So there's a flipping back and forth between chat and Q&A. So on the chat side, there's a question for chassis. Where are the different Docker instances per ASIC are running? Are they assumed to be running on the line card or centralized processor card? Yeah, so great question. For the line card SONiC, the containers are running on the line card CPU. And for the Fabric SONiC, right? The containers are running on the chassis CPU, right? Basically the RP CPU. So I think basically the idea is to put the container laying out according to the hardware architecture, the CPU location, and the distributed work. There's another one about load balancer. Two questions. At what level do you plan to put LB? Which load is being balanced, and have you considered using Kubernetes for auto-scaling control subsystem? Yeah, so great question. I think for load balancer, the typical way of people using it is for the north-south scenario, right? And certainly there are some use case for east-west, but I think north-west would be more kind of standard deployment. And for Kubernetes, certainly, yes, I think there's some ongoing work to make the SONiC container conforming to the Kubernetes pod architecture already. And we are doing some internal work right now, and probably a little bit late, we can share more details about the Kubernetes integration. I received some feedback saying there's some quality, audio quality issue. I'm not sure if people can hear. But, okay. On the other side, how are you hardening your networking solution? I saw the secure boot and MACsec are coming. Can you elaborate on that? Yes. So MACsec is actually part of the effort together with the Phi chip, right? So it's often part of the Phi chip. So you see the MACsec side has been defined jointly together with Arista, Facebook, Broadcom, and many other folks. So that is certainly coming. And secure boot is lesser about the switching ASIC, but more about how the box is designed, right? Whether there's a TPM chip. So we do have some secure boot work happening right now. As we migrate towards Debian 10 later, using secure boot might be getting easier, but it's still happening right now. And on some boxes with TPM, it's happening. I think the part of the challenging though is that the secure boot infrastructure in the box design it varies quite a bit, right? The bootloader or the BIOS it varies quite a bit between platform to platforms. So that definitely presents quite a bit of engineering challenge to for it to be universal. That's unfortunately the networking hardware is not as standardized as the server hardware at this point. Where can I find more information about Kubernetes usage analysis? They mentioned in the answer. I'm not exactly sure whether I got the question right. So the usage analysis, I'm not exactly sure what this question is pointing to. I think there's some prototype and it's still being worked on. So there's probably not much SONiC usage. If your question is about the generic KAS usage, I think that you can find it in the Kubernetes community.
Yeah, so the link I put there is actually for all the design docs. This one hasn't using Kubernetes to orchestrate all the Dockers hasn't been published yet, but it's on the agenda. For the usually for the design doc, we will put some user scenarios, but you are welcome to participate in the community meeting to actively participate in the discussing.
Seems more questions from the audience.
Yeah. Okay. With that, then we will be closing this session. We are moving to the next session. Thanks everyone for joining. Bye.
Thank you.